So what we want to do is we want to do this limiting reactant, but instead with cheese sandwiches and peanut butter and all that jazz, we want to do it with an actual reaction. Okay? So here's the combustion of methane. So I have methane, 2 oxygens, CO2 to 2 waters. Okay? So this is my balanced equation. Remember, I can only do this if I have a balanced equation. So I have my stoichiometry. It's a 1:2 to 1:2 ratio. So what I want to know is, say I start with some amounts of my 2 reactants. How much product will I make? Okay? So let's look at that. If we have 5 moles of CH4 and 8 moles of O2, which is the limiting reactant? So it's telling me how much I started off with. So I'm starting off with 5 moles of CH4, so I have 5 moles of this guy, and 8 moles of this guy. So it's telling me how much I started off with. So 5 CH4, 8 moles of O2. So I start off with my bread, and I start off with my cheese, and I want to know how much product I'm going to make. Now, so the way that we're going to figure this out is very similar to the way we did it before. Whoops. So before we said, okay, I had 4 pieces of bread. How many sandwiches could I make? 4. I had 3 pieces of cheese. How many sandwiches could I make? 3. And then which one gave me the least amount of sandwiches? The cheese. And so we figured out the cheese was the limiting reactant. We didn't really go through that process in our head and like break it down like that, but that's what we did when I asked you the question, how many sandwiches can you make? So we're gonna do the same thing. You're gonna take one of your reactants and go to the product and see how much you make. Take the other reactant, go to the product and see how much you make, and whichever one makes the least amount of product is your limiting reactant. Okay? Now you might say, well, which product do I go to? In this problem, it doesn't matter because you would get the same answer as long as you go to the same product when you're doing your comparisons. Okay? But in the wording of the problem, they're usually going to ask you about one of them, and that's how you would know. But we'll do some examples for you to see. So I have 5 moles of this guy, and I have 8 moles of this guy. And I want to know how my product. I'm going to pick CO2. So I want to know who's my limiting reactant. So I want to go from this guy to the product. How do I go from one thing to something completely different? It's the stoichiometry. It's these ratios from my balanced equation. And I can only do that if I'm in the moles. So it's kind of saving me some steps. So I have 5 moles of CH4. The only way that I can go from CH4 to CO2 is in moles. So I'm already there. So now I can go from moles of CH4 to moles of CO2. So what is that relationship? What is the mole to mole relationship? Well, for every 1 CO2, there's 1 CH4. So it's a 1-to-1 ratio. So that would give me 5 moles of CO2. So that would be taking my bread and saying how many sandwiches can I make. But now I need to take my cheese and say how many sandwiches can I make. So I have to do the same process for both reactants. So I have 8 moles of O2. I don't want O2, I want my product, my CO2. So since I'm already in moles, I can convert from moles of O2 to moles of CO2. Now, what is that relationship? For every 1 mole of CO2, I have 2 moles of O2. So it's a 1-to-2 ratio. So 1 moles of CO2, 2 moles of O2, and I get 4 moles of CO2. So I took my bread, how many sandwiches? I took my cheese, how many sandwiches? Which one gives me the least amount? This one gives me the least amount. So whichever one gives me the least amount, that guy is the limiting reactant. Okay? So what I would say now is that O2 is the limiting reactant because it gave me the least amount of product. Okay? Now don't say this is the limiting reactant because this is a product. Okay? This ends up being what's called my theoretical yield. So this is my theoretical yield because this is the least amount. This is how much I should make. So this is my theoretical yield. O2 is my limiting reactant. What is the other one? If this is my cheese and this is my bread, which worked out well, This is limiting reactant. What's the other one? Excess reactant. So the CH4 is my excess reactant. And then this guy, you end up doing nothing with, okay? He's only there as a comparison so that I know how much product I would make. All right? So looking at this, since less CO2 can be made from the O2 than the CH4, the O2 is going to be my limiting reactant. So this is how you do a limiting reactant problem. You always have to take each of the reactants and go to a product, make sure the products are the same, and see which one gives you the least amount. Okay? Now, we're going to do another example, because most of the time, we don't just start with moles, right? This was just a simplified version to see how a limiting reactant problem works. Most of the time, we have like grams or kilograms of this, because that's how we actually would measure something. So on the next lecture, we're going to actually do a practice problem, kind of going through limiting reactants in a more common scenario.